Hi everyone, it's so nice to meet those who love physics and math. Today let's talk about average speed and let us solve the following problem here. The difference between the average speed and average velocity and between the speed and velocity concepts is that velocity is the vector and the speed is scalar. It's not vector, it does not have direction. In other words, we could say that speed is the magnitude of velocity. And also we have concepts of instantaneous speed and instantaneous velocity, kind of speed in a certain moment of time. And general concept of speed is distance divided by time traveled. The concept of velocity is displacement over time traveled. So let's take a look at this text and this picture. Car travels with a speed of 15 meters per second during 20 meters, and then it speeds up and travels 24 kilometers with a speed of 24 meters per second. What is the average speed of this car? In this drawing, you see, first time, car has speed of 15 meters per second. Then after a certain time, we don't know when and where exactly. When we know after 20 minutes, but where we do not. It speeds up and speed increases, okay? Let's first write the formula for the average speed. And I believe you remember that. Sometimes we use this bar symbol above, saying that it's average one. Or, in other words, we could just write this subtitle AV, average, whatever. So it's distance traveled. Let us call it distance D over time traveled. Just we need to take overall distance, okay? Let me mark this overall or total. Overall distance divided by overall time, okay? That's the point. We do not know the overall distance and the overall time yet. We just know some parts. And what do we need to calculate them correctly? First of all, let's pay attention to the unit measures. We have meters per second. It's finally okay. You know, SI system works here. 20 minutes, it's not seconds. We have to have seconds. Let me write it down. Maybe let me first maybe enlarge this one. And 20 minutes. If each minute contains 60 seconds, just to multiply it by 60, it will be 1200, yeah? 1200 seconds. And then one more thing is that kilometers is also not SI system. We have to convert it into meters. Each kilometer has 1000 meters, means 24 kilometers have 24,000 meters. 24 kilometers, 24,000 meters. Okay. Now, let us put the basic formula into a frame like that. And let us a bit improve, not improve, just add something to this picture. Now, we know that first distance traveled, distance is also scalar, just the length of this interval. It is not mentioned yet, but we know about 20 minutes. Let me write it here that we have, let's say, T1, first period of time, 1200 seconds. Yeah? And the distance itself, we do not know yet. The second interval of the distance traveled is mentioned. It's 24 kilometers, or let's call it D2. Okay, it's 24,000 meters. Well, now what we need to find out, we need to find out the distance of the first part here, right? Basically, it's quite easy stuff. Let me do it maybe in blue color here. Distance of the first part is speed of the first part times time of the first part. Yeah. What we'll get? We'll get 15 times 1200, and that's 18,000 meters or 18 kilometers. That's perfectly okay with us. What can we do next? Let's just mark it here. So D1 is equal to 18,000 meters, like that. Cool. Now we have both parts of the distance. Distance total, let's say, overall, as we mentioned, overall is just 18,000 plus 24,000. Pretty easy to calculate. It's 42,000, I guess. You could correct me if I am mistaken. 42,000 meters. And now we have to find the time of the second part. And it is, again, by the same formula. Time of the second part is distance of the second part over speed of the second part, okay? Distance is 24,000 and speed is 24. So we have 1,000 seconds. 1,000 seconds means time overall, all the time of this travel, is just addition of those two numbers. 12,000, it's a first part, and 1,200, I'm sorry, 1,200 and 1,000, which gives us 2,200 seconds. Now let's substitute those the data to the formula. So our average velocity, let's do like this, is 42,000 meters. It's a distance traveled, total distance traveled, over 2,200 meters. And if you calculate it carefully, it will be some long decimal, but basically it's about 19.1 meters per second. Okay, 19.1 meters per second. Let us analyze what does it mean to us. Our average speed is like that. If we take a look at the interval between 15 meters per second and 24 meters per second, what is in between 15 and 24? Say here is 15 meters per second, here is 24 meters per second. It's the average, 15 plus 24, which is 39 over 2, 19.5. So this would be average, 19.5. But our number is 19.1. 19.1. You see, our number is a bit closer to 15 than to 24. 19.1. This part, left part, is about 4 units per meters per second. Right part is about 5 units. Generally speaking, in many cases, when two distances are equal and the speeds differ, or in case of the longer distance traveled with a slower speed, usually average speed gets closer to the slowest one, okay? In case slow speed interval is kind of small, then it might be closer to the greater one. Why is that so? Why for the equivalent distances of the first and second part, and why in our case average speed got closer to the slowest speed, to 15 meters per second, than to the highest speed? And why it's not an average at all in general? This is a question to you. If you have any ideas, please share in the comments. If you have desire just to know, please put I am interested, and we'll talk about it a bit later in our future videos, let's say. For now, I want to complete this small video, and if you have any questions, I will be happy to receive them and to answer. If you have suggestions, what kind of topics do you like? What is more interesting? Also, please share. I will prepare something especially for you. At this point, I would love to wish you all the best in your studies, in your exams, in your tests, wherever. Please feel good in studies, and see you. Bye.